Okay, now let us consider this example of convolution integral xt ht, that is defined as integral minus infinity to infinity x tau ht minus tau d tau. Now tell me, is there any difference in that procedure compared to the discrete time case convolution? What is the difference here? What is the difference? Is the only difference is this one? Instead of summation, now it is integration. This time is same, isn't it?
Yes, sir.
You have to flip the second signal, delay by t, everything is same. Only thing is that instead of summation, now because it is a continuous time signal, now it is integration. Let us start with this example. Let's say this is xt and x tau, ht is 0, 1. This is, this is ht. Okay. So first we have to find x tau. It is the same signal, just change the variable x tau. Now what is ht minus tau? This is ht. If you change the variable, you will get h tau. Then what is the next operation? How to get ht minus tau from h tau? Reflection and delay by what? So is this the signal? H t minus tau. And where is this point? Delay by how much? T.
T, sir.
This is t and this is?
T minus 1.
This is t minus 1. Now you have to move, this is, if you want to find the output, this is yt. If you want to move the, if you want to find the output at some instant of time t naught, what is the procedure? Move this t to t naught. Multiply these two signals. Find the area. Is it that? Now tell me what will be the shape of that output signal. If you start, I am directly sketching that yt. If we start this from minus infinity, until which point it will be 0 output? We are starting this from minus infinity and moving it towards right. Until this point reaches minus 1, the output is 0. Is it that? Now what happens? For example, if it is at 0, you have to multiply these two signals and find the area. So can you tell me what is the shape after this minus 1? Is the area linearly increasing? If this is 1 and 1, is it linearly increasing? Is it something like this? Yes. And if you want to find the integral, what will be the expression for the signal in this interval between minus 1 and 0? Integration starts from where? This point is, I am saying that this t is in between minus 1 and 0. Where will that integration start if you multiply these two signals? What is the lower limit?
Minus 1 to T.
Minus 1 to t. Sorry, is it minus? Yeah, it is minus 1 to t. But 1 into 1, so it is d tau. Is it? Is it t minus 1? Is it that?
T plus 1.
Right? Yeah, t plus 1. Is it this? T plus 1? What? What is t? T is this. If you shift it left by 1, you will get this, isn't it? That is t plus 1. Now what will happen after this? You don't need
Constant.
to find this integral, because in this case both are rectangular pulses, so the area will increase linearly. And after that, what will happen? Until this reaches 1, can we say that this rectangle is completely inside this?
Yes, sir.
Then when you multiply these two and find the area, what will be the area? Will it be a constant?
Constant.
Constant.
Yes, yes.
It will remain constant until which point?
1.
T equal to 1.
Until this point reaches 1. So this is 1. After that, what will happen?
Again
Decrease
decrease linearly.
linearly.
Decrease linearly until t minus 1 reaches 1. That means when t is 2, then it will be 0. Okay. So this is the convolution of these two signals. Okay, now let us consider a slightly modified version of this. Suppose this is the same minus 1, 1, and if we want to convolve this with this 0.5 minus 0.5. What is the difference? Here the signal is from 0 to 1. I shift it left by 0.5. Then you will get the signal. Is it? Now what is the convolution of these two? What is this is ht. What is ht minus tau? First you have to make this ht, then flip it, delay by t. So what will be the signal? Okay, let me draw it here. It will be is it something like this? Depends on the value. Which point will be this? This is what? Flip
T
this
plus
signal.
0.5.
T plus 0.5.
It is t plus 0.5 and this is t minus 0.5. Is it that? Because 0 will move to t. So this point will be t plus 5 and this is t minus 5. Now you move, this is t is somewhere here. Now you move this t from minus infinity to infinity. Tell me the shape of the signal, output signal. What will be the output signal? If you are moving this t from minus infinity to infinity until this point reaches here, up to where? Up to?
Minus 1.5.
Minus 1.5. It will be 0. When this reaches this point, that is minus 1.5, then what happens?
Increases linearly till
Increases
T equal
linearly till
0.5.
minus 0.5. Then
Constant
constant till
till T equal to
till this
0.5.
point reaches this. That is t, that is 0.5. Then decreases
Decrease
linearly. Okay. Now tell me, what is the difference between these two convolutions? Here what we are doing? We have shifted this left by 0.5. Now what is its effect in yt? Yt is also shifted left by 0.5. Is it that? Here we considered convolution of these two signals and this is the result. Now in this convolution I have shifted this left by 0.5. You get this signal. Now what is the convolution of these two? Is it this delayed by this? This is called the time delay property of convolution. We'll prove this later on. Okay. Okay, now just one more example. What is the convolution of these two?
So can you explain that convolution diagram once? How
Which-
it is getting?
Which one? This case?
Yes, sir.
Okay, we want to convolve these two signals. This is xt and this is ht. Okay. Now what is convolution? Okay, what is convolution integral? Integral minus infinity to infinity h tau xt x tau ht minus tau d tau. Here the variable is tau. So we have to get first x tau. What is x tau? The same signal. Is it this? We just change the variable x tau tau. This one from 0, 1, minus 1. Now here t is a constant. Start with h tau, h minus tau, and then what?
Shift by t units.
H t minus tau, you will get this operation is t to minus t, and this operation is this is tau to minus tau, and this is tau to, what is the delay operation? Tau minus t. You are delaying it by t. Now what is h tau? H tau is this 0.5 minus 0.5. What is the flipped version of this? It is an even signal. So flipped version is also same. So this is h minus tau is also same. Now how to find this h t minus tau? You have to delay this by how much?
T units.
You have to delay it by t. Then where will this move? This value. I am not talking about the axis. Axis will remain the same. I am talking about the signal value at this particular instant of time.
T minus 0.2, t plus 0.5.
So is the signal shifted signal is something like t plus 0.5, because this point moves to t plus 0.5 minus t. Sorry, what is that? T minus 0.5, isn't it? Okay. Now what is the procedure? If you want to find the output at some time t, move this t to that time. For example, if you want to find yt naught, move this t to t naught. Multiply these two signals, find the area. So let us start from minus infinity. So I'm not drawing the y-axis. This point is t plus 0.5 and t minus 0.5. This is t. Now if I am moving t from minus infinity to infinity until this point reaches minus 1, will there be any overlap between these two?
No, sir.
No. So we can say that the output signal is 0 till when? Till?
Minus 1.
Till this point reaches this. Till t.5 is equal to minus 1. So this is minus 1.5. Is it? Now what happens? If you keep on moving towards right, that there will be overlap between these two. And there will be partial overlap, and so the area increases linearly. Is it? Is it that?
Yes, sir. Yes, sir.
It is linear increase in till which point? Till this point reaches here. Till this reaches here.
Yes,
and
sir.
Where is that point? Minus 0.5. Is it? When t
Yes.
minus 0.5 is minus 1, t is minus 0.5. After that, there will be complete overlap. This rectangle is inside this. Is it that? Completely inside that. So if you multiply these two, that area is always 1. Now what will happen?
Again, it will decrease linearly.
From where? From which point? Till 0.5, it decreases linearly, and then when this point reaches here, it will become 0. Is it that?
Yes, sir.
Okay, now tell me this one. Convolution of these two. Let's say this is 0, 1. This is xt. Convolution ut. What is the convolution of these two signals? Now I'm not going to draw the intermediate signals. You have to visualize everything. What is the convolution? You have to flip this. Then this point will become what? Flip and delay by t. This will become
T.
t. Then move the t from minus infinity to infinity. Okay, for this I am drawing it. So this will be t, u minus t flipped version. Then you move this from minus infinity towards right. Then until this point reaches here, there will be no overlap. And then what will happen?
Increasing
It will linearly increase
Increasing
till
linearly till
1.
till 1 it increases linearly. After that
constant.
it
It's a
remains a
constant.
constant, isn't it? It remains a constant. Okay, let us consider this. There is a switch and there is a 1-volt source. You must have studied this type of circuits in your 291 course, isn't it? Have you studied this type of?
Yes, sir.
Yes, sir.
Okay. So for simplicity, I am assuming that RC, the time constant is 1. There is a switch. It is initially in this position. At t is equal to 0, it is moving towards this, and it will remain in that position till. So I am drawing it here. This is t is equal to 0. It is moving this position, and then t is equal to 2. It is moving back to the original position. Okay. Now, before considering it as without considering it as a linear time invariant system, let us first find the voltage. Our objective is to find the voltage across the capacitor. Let us first find this voltage using the analysis method you studied in your circuit theory course. Tell me, what is the voltage here? What is the voltage for t less than 0? Assume that the capacitor is initially uncharged. For t less than 0,
0.
there is no voltage source connected. It is 0. By t is equal to 0. Okay. Now, when the switch is in this position, in which interval it is in that position? It is moving towards left at 0 and
0
then.
to
So, if you consider this interval, t between 2 and 0, what happens? What is the equivalent circuit? Is it this? Plus minus 1. Is it this in the interval RC? Plus minus YT. This is 1 volt. Now tell me, what is the voltage across that capacitor? What is the expression? YT is? Is it charge E of a capacitor? Hello?
Yes,
sir.
sir.
So what is the expression for that voltage across the capacitor? Is it 1 minus e to the power minus
E
t?
minus E by RC.
RC, I
Yes.
am assuming that RC, time constant 1. 1 minus et. Is it? Now what will happen for t greater than or equal to 2? What is the equivalent circuit?
Discharge.
Is this? It will discharge, the capacitor will discharge through this resistor. Now what is the initial voltage at t?
So 1 minus E to the power minus 2.
Minus 2. Minus 2. Now tell me, what is the expression for t greater than 2? This is the initial. What is the capacitor discharge? That equation. Initial voltage into e to the power minus.
T.
T minus 2.
Is it t or
Yeah,
t minus
yeah.
2?
T minus 2.
It is t minus 2. Why? T minus 2?
Sir, because it is starting at T equal to
Because
2.
it is starting at t equal to 2, isn't it? It is delayed start, isn't it? Delayed discharge, let's say. With respect to that reference point, it is starting t minus 2. So is this, now we have found the voltage for all the, means output yt for all the intervals, isn't it? Is it? So this is how we find the output using normal, say your circuit analysis techniques. Now let us consider it as a convolution. We are considering a system R, RC circuit, RC, and this is the voltage yt. I am considering it as a linear time invariant system with input xt. What is this xt? Is it this? 0, 2, 1. Till time 0, it is short circuit. Then you are applying a voltage 1. So this voltage will be 1. And then, is it this? Yes or no? Is
Yes.
it the same as that what we discussed earlier? This closing of this switch. This is equivalent of that. Till 0, this is short circuit. 0 voltage means it is short circuit. That means the capacitor voltage is 0. Then you are applying a 1 volt voltage source till 2, and then again short circuiting that. That means discharging. Is it? Now, if we consider it as a linear time invariant system, what is the, I think in the previous class we found the impulse response of this. What is the impulse response of this? Impulse response of RC circuit is, this RC integrator is RC e to the power minus t by RC ut. You check the previous notes. Now here we are assuming that it is 1 by 1 RC time constant is 1. So its impulse response is e to the power minus ut. Okay. Now let us find the output corresponding to this. This is a linear time invariant system with impulse response e to the power minus t ut, and you are giving this as the input. Then what will be the output? Is it this convolution? This is e to the power minus t ut. Is it this convolution of these two signals? Because it is a linear time invariant system. Is
Yes,
it?
sir.
Yes. Now let us try to find out this convolution. And here again, using the commutative property, you can flip any of the signals and slide it. I am choosing this one. That means I am keeping this signal same. This is, we have to make it as a function of tau. So this will be e to the power minus tau u tau. Okay. And then flip this. Where is this? This is 0, 2. And flipping this and delaying by 2 t, then tell me which are these points. This point is what? Where is this point?
So T.
This is
So
t,
T
and
and
this is
minus-
t minus 2. Okay. Now if we start, then we have to slide this point from minus infinity to infinity. So until t reaches where? T less than 0. What will be the output?
0.
The output is yt is 0. Then what happens? Then this overlap starts. When will be the in which interval will be the there will be partial overlap? Until this point reaches here, there will be partial overlap, isn't it? So can we say that between 0 and which interval? Until this t minus 2 reaches 0, that means t is where?
T is less than 2.
Less than 2. Now what is the integral? Convolution integral. This is 1. So is it my from where to where? Integration from where to where?
0 to t.
Integration from 0 to t. Okay. 0 to t. Then
E to the power minus t.
e to the power minus tau d tau.
d tau.
Is it? Because then this is in this interval. When this t is between 0 and 2, there is partial overlap. Then what happens for t greater than or equal to 2? What happens? What will happen? Where is this point? It is beyond the 0, isn't it? If t is greater than 2, t minus 2 is greater than 0. When you multiply these two, what is the limits of that integration?
T minus 2 to t.
T minus 2 to t e to the power minus tau d tau. Find these two integrals, you will get the same answer. Okay. Here I am considering it as a linear time invariant system. Now, which method is easy? This one or your normal circuit analysis technique? In this example, you can say that the normal circuit analysis technique is easy. But problem is that suppose this is a very simple input. There is a step increase in the voltage and then back to normal. Now, what if you want to find the output of this circuit for some input like this? Can you use your normal circuit analysis technique? Do you know the capacitor charging equation for linearly increasing voltage? If the voltage source is constant, you can use the normal technique. But so what will be the output corresponding to this? Can you use your normal circuit analysis techniques to find the output corresponding to this? That is my question. Hello? Am I audible?
Yes, sir.
So
we would have to solve equations.
Yeah, you will have to solve
the
the
answer.
equation, that differential equation, isn't it? So in this case, if you know the impulse response using this convolution, you can very easily find the output. For any arbitrary shaped input signal, if you know the impulse response, find the convolution. And later on, we will discuss even simpler method, that is using the Laplace transform. I don't know whether you have studied it in your circuit theory. Is it discussed already? Circuit analysis using Laplace transform?
So last semester we had a course in which we studied Laplace.
I know that is a circuit analysis using Laplace transform. No.
No, sir.
No, but
Yes,
we will also discuss in this course circuit system analysis using Laplace transform. Okay. So this is how we do the convolution, and please practice few problems because this is visualizing this convolution is very important. Okay. These are very simple examples, and in the tutorial sheet you will see difficult problems. But if you can visualize it properly, there is no issue. Visualize means mainly finding this limit of this integration. In which interval that limit changes.
Excuse me, sir.
Yes.
Sir, can you please explain why we took that convolution over there in this example?
No, I am just giving an example. You can solve this using different methods. Normal circuit analysis method also you can solve this. And here I am considering it as a linear time invariant system, and then using the impulse response I am finding the output. Okay. So the advantage of this method is that if you are given any arbitrary shaped signal, you can easily find the output using the convolution integral. But using the normal circuit analysis techniques, it is difficult. If it is a constant voltage, you know the capacitor charging equation, isn't it? If it is not a constant, then if the voltage is not a constant, then it is difficult. Okay. In that case, this LTI model is useful. Is it? Because you have to find only the convolution.